All right, this is the video for Sedimentary Rocks Part 2, and the topic of this video and the question that you are trying to answer is, how do sedimentary rocks form? So my expectation is that you watch this video, you take some notes to answer that question. There are 3 ways, so you want to focus on what are the steps in each of the 3 ways. I have some important words highlighted in different colors throughout the video, and so that's what you're going to want to put in your notes. Answering that question. How do sedimentary rocks form? The term lithification is sometimes used, and it is the process of turning loose sediments into solid rock. You'll notice that litho in lithification is the Greek word for stone. You might recognize that from the word lithosphere that we had earlier in the year, which means the stone sphere, the layer of stone that surrounds the outside of the earth. And so we're going to look at the 3 ways that we can lithify sediments. The first type, the most common type, is with clastic and bioclastic sediments. So you should remember from the last video that clastic means pieces of other rocks. And so most of the sedimentary rocks that you see around the classroom will form in this way. The way in which this process starts is with sediments being moved in some way. Usually water moves them, like rivers moving part sediments, or glaciers, or even wave action in the ocean. But sometimes water's not involved, like with wind moving particles. Regardless, sediments are moved. And the first step in this formation process is that those sediments are deposited in some place. Deposited means dropped off. So you'll notice that word is in red because that is going to be a term you're going to want to know. Typically, or oftentimes, when sediments are deposited, horizontal layering occurs with these sediments. That layering stays with those sediments when it's turned into a rock. And so later on, when we find those sedimentary rocks, we often see horizontal layers, a result of this first step, deposition. So the first step, those sediments are dropped off. The second step is that those sediments are buried by other sediments. So over many years, layers of sediments will continue to build up in the same spot, and those sediments that are deeper are considered to be buried. Because they're deeper, they hit the third step here, which is compaction. And so the sediments are compacted. And it's that weight of all the sediments on top that are squeezing the sediments together and at the same time squeezing out the water that's in between those individual sediments. Step number 4 doesn't always happen, but it is pretty typical. And that's that the particles, sediments, are cemented together, or cementation occurs. This happens because there's natural glues or cements that are dissolved in water. And so when you squeeze that water out, those cements are left behind and glue the particles together. And so if you look at page 6 of the reference table, this first way in which sedimentary rocks are formed is basically laid out. You see in the upper right-hand part of this rock cycle diagram, you start with loose sediments. And those sediments are deposited and buried, then compacted and cemented in order to form the sedimentary rock. So even if you can't quite remember, the reference table is there to help. So those 4 process words, deposition, burial, compaction, and cementation, are listed in the reference table. And so these processes are basically happening in your backyard right now. Here I have a picture of atop Jay Mountain. And what you see is some weathering has occurred in the bedrock, and you have these smaller pieces broken off from the bigger pieces. So you can see, the smaller pieces in the middle of the picture, and the larger pieces that they came from or that they weathered from are on the right and left side of this picture. Then those particles are carried somewhere. The word for carried is eroded. So we weather the particles to make them smaller, and then something, something done by Mother Nature, carries or erodes those particles away. In our area, it's the Ausable River that carries a lot of particles of all different sizes, and it carries it from the mountains, essentially downstream and out towards Lake Champlain. Eventually, though, those particles stop being carried and are deposited, and oftentimes it's where the rivers slow down significantly, and that happens when the Ausable River meets Lake Champlain. So here's a picture of a beach along Lake Champlain, and sand is the sediment that's being deposited there. The next two steps I don't have pictures for because they happen underground. The sand is buried by other sediments, and it's compacted and cemented together. And over a long period of time, the loose sand is changed into a sedimentary rock. And so the rock sandstone would be formed. Then many years later, you could uncover those rocks. They could be brought to the surface by Mother Nature, and we would see it as sandstone. And so here's a picture of a couple chunks of Keysville sandstone that I stepped over while I was hiking up Poca Moonshine. So that's the main way in which sedimentary rocks are formed. Sediments of some size are deposited in a location, they're buried by other sediments, they're compacted together, and they're oftentimes cemented. And you'll notice that during this description, I've mentioned many ways in which water is involved. So we'll see that in the formation of sedimentary rocks, it typically occurs where you have water. And so rocks that we might be familiar with that form this way are sandstone. And so here's a picture of a sandstone, sand-sized sediments that were compacted and cemented together. The sample in the picture has some nice horizontal layering as well. This is a rock called conglomerate. It's basically all different size sediments that were compacted and cemented together. This rock's name is shale. It has the smallest size sediments. We call that size clay, and those clay sediments have been compacted and cemented together. This rock called limestone has shells that have been compacted and cemented together. The next type of formation happens with crystalline sedimentary rocks. And so what we first must realize is that water, even though it may look clear, has dissolved minerals in it. So things like halite or quartz or calcite, many different kinds of minerals can be dissolved in water. And during the second formation type, we get those minerals to come out of the water in some way. And so the two types of sedimentary rocks formed this way are called evaporites, you see that word in red, and precipitates. You'll see that word also in red. Now the processes are just variations of those two words. So we would say that the water undergoes evaporation and it leaves the minerals behind. And so this happens typically with warm seas. You have a salty sea, and as the water is evaporating, crystals of salt, the mineral, possibly halite, are being left behind and will collect on at the bottom of that warm sea. And over a long period of time, you'll build up layers and layers and layers of that mineral. And that's how evaporite sedimentary rocks form. The other method is similar, except the water isn't evaporating directly. Essentially, just the minerals that are in that water are being precipitated out. That is, they attach themselves to something else and the water washes away. And over time, you can build up those mineral crystals. And so in this picture, what I'm showing you is a small, warm, salty sea. And this is the process of evaporation. The water is evaporating away, leaving behind the mineral crystals. And you can see all that white coloring on the left side of this salty sea would be a crystalline sedimentary rock forming. This is how rock salt forms. And so here's a picture of a salt mine. Again, it is a sedimentary evaporite. This is kind of a well-known example. In the right side of this picture, you can see a map showing Salt Lake City in Utah and the Great Salt Lake. And to the west of that, you'll see an area labeled the Bonneville Salt Flats. And what this area is a giant flat bed of layers of halite or rock salt. And what you have to imagine is that at some period of time, this was a salty sea. And as the water evaporated away, the halite was left behind. This is a pretty incredible picture of a cave, a limestone cave, and you can see the crazy amount of stalagmites and stalactites that have formed. These are precipitates. So what we didn't see happen, but happened over a period of time, was you had water running along the ceiling of this cave. The cave had formed a while ago by a different process, which we will eventually get to. But you have this hole in the rock, and water is dripping from the ceiling, except that water has a mineral, calcite, dissolved in it. And as the water drips away, those calcite crystals get left behind, or we say precipitate out. And these long pointy structures grow from the ceiling. At the same time, the dripping water is striking the floor. And as it flows away, it leaves behind small crystals of calcite. And those small crystals build up from the floor and grow towards the ceiling. If you would like a bonus, you tell me which are the stalagmites and which are the stalactites. Put it on an index card and put it in the slot. So these are precipitate sedimentary rocks. This is an icicle, and this is a precipitate. You can see in this picture small ice crystals that are in the middle of that drop of liquid water at the end of the icicle. And so as the water drips down the icicle, small crystals are forming and sticking to the rest of the icicle that's there, or precipitating out of the water. This last picture for the second formation type, the evaporation or precipitation type of sedimentary rock formation, is a geode. And so what happened here is similar to the cave, but probably on a smaller scale. So you had a cavity in a rock, a hole, a cavity, just like holes in your teeth. You have a cavity in a rock, and as water was flowing through this cavity, it was precipitating out mineral crystals. Eventually, over time, these crystals grew and formed this structure. We busted that cavity open sometime later and found this geode. This happens to be the purple variety of quartz. You may remember this from the Mineral Identification Lab. This is amethyst. Other rocks that form this way are rock salt, rock gypsum. What you should be noticing is that this type of formation is giving us rocks that have basically just one mineral as their composition. The previous type of formation, where we were sticking sediments together, you were getting all different minerals being compacted and cemented together. This type of sedimentary rock, typically we would say they're monomineralic. It's just a fancy way for saying these are sedimentary rocks that have just one mineral as their composition. These last four pictures are all of limestone. So what we're going to see when we do the lab is limestone can take on a lot of different appearances. This is just a neat one I threw in. There's many different kinds of sedimentary rocks that form this way, but kind of a neat looking one is agate. And so I have a bunch of agates in the display case in the front of my classroom. Please walk up and check them out. But essentially these are layers of quartz that was dissolved in water and then precipitated out. Small impurities give it the different colors of the layers, but the result is rock agate. The last type of formation is going to be unique to coal. Coal is a very unique rock. I mean, obviously it has been used for energy purposes for a long period of time, but it's unique in that it is one of the few rocks that does not contain minerals because it's made of all organic matter. And so coal starts off as just plant material. And you can see the 4 stages of coal formation here. But really what we should focus on is this, that it starts off as plant material and that it's buried and compacted for many years. Many is probably an understatement. And then eventually that plant material is turned into the rock coal. And so the coal that we see, or that's mined currently, is over 100 million years old. Most of it's over 200 million years old. Coal starts off as typically in a swampy environment. So all this organic material, whether it's leaves or branches or whatever plant material it is, falls to this swamp floor, possibly under the water, and it is buried by other material over time. And so we have those same 2 words that we had from the first formation process. So formation process number 1 was deposition, burial, compaction, cementation. With the formation of coal, we just really use 2 of those terms. We use burial, so that plant material is buried. And over time, the weight of those overlying sediment causes compaction. And eventually, with a lot of burial, we get bituminous coal to form. If you look to page 7 of your reference table, you'll see the scheme for identifying sedimentary rocks. And so we're going to use this a lot when we do the lab. But what you'll notice is that we essentially have 2 classes here of 2 groupings of these sedimentary rocks. So the first group of top of the first 5, those are those inorganic land-derived sedimentary rocks. You see this up here. And so those are formed by the first formation process, that we have some sediments that are compacted and cemented together. The bottom category here, you'll see that it's broken up 2 main terms. We have chemically and or organically formed sedimentary rocks. So this is going to be the other varieties. You'll notice we just talked about coal. So it's by itself kind of at the bottom here, it's its own animal. Then we have these crystalline sedimentary rocks, the rock salt, the rock gypsum, and the dolostone, but you also have one variety of limestone that is also a crystalline variety. And so these are going to form by that second formation process. The one kind of twist in this key here is that we have 2 versions of limestone. So you'll notice that we also have cemented shell fragments. So the term cemented should remind you of the first formation process we talked about that went along with these first 5 clastic inorganic sedimentary rocks. So I think that's it. That's probably a lot to digest. Hopefully at this point you have something written down about how sedimentary rocks form. If not, please go back and rewatch this video, or feel free to use a reliable outside source to try to answer this question.